Now sometimes I want to communicate a concentration to someone who isn't in chemistry, who doesn't know how to convert grams to moles. And sometimes I have applications where I don't really need to express my concentrations in terms of moles. When do we use molarities? We use molarities mostly when we are talking about compounds that are reacting with each other in solutions. We'll make up a solution with a molarity so that we know how many moles of the solute that we've got in a reaction. And if I'm not doing that kind of work, then I don't really need to use moles. Now, what people use most often when they are they're not using molarities is percent concentrations. So they use a percentage. Here I've got some vanilla extract. If I go and try to, let's see if we can see the label. Zoom in on that. It says 13% alcohol, and it also says I have 59 milliliters of solution in here. Okay. So 13% alcohol. And the label also said, and I'll put this over on the side because we'll use it later. Now, it doesn't matter what the volume of solution here is, the concentration is independent of the amount of solution that you've got. They're saying when they made this up, that they made it up to be 13% alcohol no matter how big a bottle you bought. But what does this mean? Okay, percent means per 100 parts of solution. Let's write that a different way. What this means is that you have 13 parts of alcohol per is divided by 100 parts of solution. The vanilla extract is the solution in this case. Okay, now this gives me a relationship between parts of alcohol and parts of solution. It kind of tells me how to make up the solution too. Put 13 parts of alcohol in and then add water or whatever it's dissolved in, add your solvent until the mark comes up to 100 parts of solution and mix it. So that number tells me how to make this solution up. But what does parts mean? That's the problem. That's a little bit ambiguous. Parts can mean different things depending on the situation. Depends on what's convenient for you. If you've got a liquid, maybe you want to make parts be some liquid unit, like milliliters is pretty convenient. And if you've got a solid, maybe you want to make parts be grams. Now, you could use any mass unit here or any volume unit here, but these are two convenient units for us. Now, what do you think that they used for parts here in my vanilla bottle? Well, alcohol is a liquid, and the vanilla extract is a liquid. So I think that they meant 13 milliliters of alcohol per 100 milliliters of solution. Now, if you're going to be a doctor or a nurse and you're delivering some kind of medication with a very concentration sensitive dose, you don't want to say, well, I think it's going to be milliliters, right? I mean, that's a reasonable thing to think, but we're not sure. Now, you can write the percentage a better way than they did on the bottle. They didn't really care too much. They wanted to give you a rough idea how much alcohol was in there, but they didn't care all that much. If you put grams there, that's a whole different concentration because 13 milliliters of alcohol is not the same as 13 grams. So this does matter. So here's how you could have written it down. they'll use a symbol here, V over V. That means volume over volume, and that means use milliliters for alcohol and use milliliters for the solution. Now there are other ways to write this down to make it clear. You could have said 13% weight over volume. In this case, if they put a W there, that means that you put grams up there and you put milliliters on the bottom, milliliters down here. So if they wrote this, you would have to write this as 13 grams of alcohol per 100 milliliters of solution. And there's a third combination. You can guess what it is. If you're using W's and V's here, you can have all W's. If you have 13% W over W, that means use grams on top of the percentage and use grams on the bottom. Now, the important thing about this percentage is that it can be used as a conversion factor, as well as a recipe for making up the solution. You tell somebody that concentration, they know how to make that solution up now. Just take 13 parts alcohol, bring it up to 100 parts of solution by adding solvent. So let's use it as a conversion factor that relates parts of solution to parts of alcohol. Let's go back to the volume of the solution in the bottle. And let's see how much alcohol is in the bottle. This is a unit conversion problem. I am trying to turn the 59 milliliters that's in the bottle into milliliters of alcohol. All right? So I need a relationship between milliliters of solution and milliliters of alcohol, and the percentage is it. Now, if this is a V over V conversion, I can write 13 milliliters of alcohol equals 100 milliliters of solution. Now notice percent is always per 100, so I'm not going to be tempted to put the 59 milliliters down there, right? That wouldn't make sense. So here, is it? This is all I need. I can turn this into a calculation now. And I'm writing solution in. I'm going to use SOLN a lot as we go along, just as an abbreviation for it. I'm writing not just milliliters, but milliliters of what? Because I have two different kinds of milliliters here. They're actually two different units. I'm going to turn this into a fraction. Remember this? What goes on the bottom? Well, milliliters of solution is on the top, so I know milliliters of solution has to go on the bottom. There's 100 milliliters of solution, and there's 13 milliliters of alcohol on top. So I can pick up my calculator and just grind that out. 59 times 13 divided by 100 gives me 7.67 milliliters of alcohol in the jar. What about my significant figures, though? Still have to worry about that stuff. Well, what's the weak link? That only has 2. So they're saying give or take a milliliter in that jar. And the percentage only has 2 significant figures. Look at the 100 as being an exact number, and then this one's the approximate one. So you really only have 2 significant figures, so you should report your final answer like this. All right. Now, let's look at converting between percent concentrations and molarities in the next video.